In this video, I'm going to show you and argue the exact opposite of what I argued in the previous video. That the answer the AP gave is absolutely the correct answer. That it should be this choice. That the acceleration should be negative. And why that's a reasonable solution. If we define the average horizontal acceleration is the constant acceleration that will produce the same delta V in the same amount of time. Well, if that is true, then that average acceleration will be delta V over delta T. And delta V is V minus V0 over delta T. So that average acceleration, the final velocity, is minus 0.5, minus 1/2. And the initial velocity is 0, and the time over which that happens is 3 seconds. So that's minus 1/2 times 1/3, which is minus 1/6. So the average acceleration would be minus 1/6. Now that's opposed to what we came up using the other technique, that the acceleration is positive 1370 seconds. Positive 1370 seconds. Now, if we use this V equals AT plus V0 to see if it actually produces the result, we have minus 1/6 times 3 seconds. Our initial velocity is 0. That gives us minus 3/6, which is minus 1/2, which is indeed what the velocity is at the end of 0.5 seconds. So if we use this technique, it will allow us to replace this whole event with one constant acceleration, and it will produce the same delta V. We see that. We calculated it. We got minus 1/6. It does yield that result. However, if we use that acceleration, initial velocity of 0, initial position of 0, we have 1/2 times minus 1/6 times 3 squared. We get minus 1/12 times 9, which is minus 9/12, which is minus 0.75. But we know that is impossible because this positive area is larger than this negative area. So the displacement must be positive. Moreover, if we were to calculate the average velocity, this being 0, our average velocity would be this final velocity over 2. So our average velocity would be minus 1/4. And if our average velocity were minus 1/4, V bar is delta X over delta T, then it ought to produce the same displacement. Minus 1/4 times 3 would give us minus 3/4. Now you'll notice that this minus 3/4 is the same we got as plugging into this, but they are both wrong. So what gives? The first thing that gives, this is a really poor question. And one could probably make a better argument that the AP is wrong with the answer about this. Because using this technique, the only thing it allows you to do is predict the final velocity. It doesn't allow you to get anything else right about this behavior. It doesn't allow you to predict the right displacement. It doesn't allow you to predict the final average, the average velocity. Whereas using the other technique, using constant acceleration that will yield the same delta X, not only gets us the correct position, it gets us the proper displacement, a proper average velocity that's all internally consistent. Using the AP's interpretation of what the average horizontal acceleration would be, it's the constant acceleration that will produce the same delta V. Well, which is it, folks? Which one does the AP want us to do? We don't really know. Which one describes the final position? and the average horizontal acceleration. As you can see, defining it as the constant acceleration that will produce the same delta x gives us more parameters to the problem that match reality. Using it as that'll produce the same delta v, the way the AP answered it, gives us fewer things that conform to reality. And all of this arises from the fact that the acceleration is not constant. So it's a poor question at best, but the better answer is not the one the AP gives.